Behind a locked fence lay dozens of corpses in varying stages of decay. It's known to some as the Body Farm. This one-of-a-kind facility covers almost 3 acres.
So you're right now at the Anthropological Research Facility, which is a part of the Forensic Anthropology Center here at the University of Tennessee. We started this facility in 1981. The main focus of our existence is to study human decomposition.
Under each of these plastic tarps is a body. But some also lay exposed. Some are placed in cars, and some are hidden underground. More than 150 populate the property. Each has been donated for the purpose of study. And as it turns out, the dead can weave long and intricate tales for trained receptive experts.
It's extremely important to study human decomposition. One of the major things that people ask for is how long has someone been dead? What is that post-mortem interval, as we call it?
But the length of time a person has been dead isn't that easy to establish.
Time since death is very important because perpetrators typically have an alibi. If you can determine that they don't have an alibi at the time when the time since death has been determined for an individual, you could possibly pin the perpetrator to the crime.
There are 4 major stages of decomposition that human bodies undergo. The first is the fresh, or autolysis stage, in which cells and organs begin to chemically break down. That breakdown generates the growth of bacteria that eats away at the soft tissue, generating gases which begin to bloat the body. That bloating, or putrefaction, is stage 2. The third stage is decay, when the body eventually ruptures and all liquids and gases escape. At the end of the third stage, only the bones remain. The final stage is skeletonization, the deterioration of the bones themselves, which will take thousands of years.
This donation is what we consider advanced decomposition or initial skeletonization. One of the first things that becomes skeletal is the skull, and a lot of that has to do with the fact that you have more openings in your head and you have less tissue on your head. And then one of the last things that tends to kind of go away is the torso area, which is right here. And a lot of that's because if you think about how much muscle and how much tissue you have in those regions.
These bodies provide valuable insight for forensic students and officials from all segments of law enforcement, from local to federal agencies, who come here to learn what a corpse can teach.
This particular one appears to be an end of active decay. And one of the interesting things about this particular individual is the formation of what we call adipocere, or grave wax. It's very cheesy and kind of, gooey material. By looking at the composition and structure of the adipocere, determine whether it was a very rapid decompositional process or if it was very slow. Rapid decomposition ends up with very crumbly type of adipocere. Slow decomposition is much more paste-like.
Insect activity is a key tool in determining a timeline of decomposition.
There's a specific reason that flies lay their eggs on the body in a certain location, why they hatch. I mean, this is a very important point to realize that the maggot mass doesn't just appear for no reason. Knowing all these things is all very important in doing forensic investigations.
A corpse can even tell investigators where it's been.
Here you have what we call true skeletonization, where there isn't any remaining tissue. You can see every element from the skull to the feet. This is the top of your head, and you can see it's much lighter in color. And then you move down and you have very dark colors, and that's because they were covered.
The bones absorb the color of the surrounding soil, making them difficult to see. So how do you find a corpse that's buried or covered in the middle of nowhere?
My 2 areas of expertise include determining how long someone's been dead and doing clandestine grave detection. Here we see an example of a clandestine grave. A fresh grave, which is usually just a couple months old, will have a nice mound of dirt where the perpetrator refilled the grave after putting a body in there. As the decomposition process continues, the soft tissue liquefies and the ground sinks and subsides. But as time progresses and this thing fills back in with leaf debris and sticks and limbs like we see here, it becomes very, very difficult. And that's part of my research efforts here, is trying to determine how to locate these graves to make the investigator's job much easier.
Arpad Voss also oversees the longest-running study at the facility, going on since 1990.
In these particular graves, we have a piping system, and each one of these is at a different depth. The reason we did this piping system is so we can watch these volatile compounds called VOCs as they migrate up from the body through the soil column to the very surface.
The volatile organic compounds comprise an unmistakable smell, the odor produced by a decomposing body. And this so-called sweet smell of death is more chemically complex than anyone thought.
Through this study, we've determined that over 450 compounds are liberated during the decompositional process. These are all found at the body. And as these odors and compounds and gases, so to speak, migrate up through the soil column, the list gets winnowed down to about 30 that are really prominent at the surface and that we've found to be reproducible body to body.
The goal of this study is to decipher these 450 compounds and create a sniffing technology